three general furnace efficiencies that you'll find in the field today. The first level of furnace efficiency predates when the government had minimum efficiency standards. You'll only find this on older equipment that's still operating in the field. They are termed standard efficiency furnaces, and they can no longer be manufactured or installed in the field today because they do not meet the minimum efficiency ratings mandated by law. These systems almost always involve a standing pilot ignition system with a thermocoupling. They also are a system that vents combustion products outside by the natural draft caused by the convection due to the heated gas products themselves. These systems have a draft hood at the end of the heat exchanger where the venting system begins to help increase the dew point temperature of the moisture in the gas combustion products. That helps prevent condensation of moisture from forming and rotting the metal and masonry material products that are used for these furnaces' venting systems. These systems are also the least efficient and operate at efficiencies typically below 70% and have the highest venting temperature, which can exceed 400 degrees Fahrenheit. These higher temperatures are necessary in order to promote good drafting of the dangerous gas combustion products and avoiding moisture condensation that will ruin the vent system itself. The high temperatures require the use of metal and masonry and less frequently asbestos chimney material, which needs special consideration. The key characteristics of these venting systems are as follows. 1. A draft hood with a single layer metal vented pipe, often tied into a masonry or B-vent chimney. 2. A standing pilot ignition system. And 3. No type of fan for the vent system. The second level of efficiency is the lowest efficiency rating allowed by government regulation. It is known as the mid-efficiency or 80+ furnace because they have an efficiency range of 80 to 84%. These still have relatively high vent temperatures that exceed 350 degrees, requiring the use of metal venting, typically double-walled type B gas vent material, because the lower gas vent temperatures can condense if they cool too much, which will rot the B vent. These furnaces come equipped with a combustion draft motor at the end of the heat exchanger that discharges directly into the beginning of the venting system, so the need for a draft hood is eliminated. You can identify these systems by 1. A draft motor assembly at the end of the heat exchanger discharging into the metal double-wall B vent material, and 2. No draft hood. The last furnace is the high efficiency or 90+ furnace, which we have a few examples of here. They have an efficiency rating ranging from 92 to 98%. They extract so much heat from the flue products that condensation of the moisture in the flue gases occurs, and this extra heat pulled out of this moisture is what really boosts the system efficiency and causes extremely low venting temperatures ranging around 120 degrees Fahrenheit. These furnaces come equipped with a combustion draft motor at the end of the heat exchanger that discharges directly into the venting system, and a draft hood is eliminated. Special heat exchangers are designed for the condensed flue gases, and the low vent temperatures require the use of PVC pipe, which is well suited to handle the condensed flue gas moisture as well. Metal venting systems are almost never used because only stainless steel could handle the condensed moisture. This is extremely expensive material compared to PVC. It's easy to identify this system because the draft motor at the end of the heat exchanger discharges into PVC pipe, and sealed burners allow the combustion air to be brought directly from the outside. Well, that's it for furnace efficiency and venting. In the next lesson, we will look at adjusting manifold gas pressure.